decided to work on Newton's law, a topic that most of you struggle with. So I'm just going to do one question, then I will leave it from there. So this is basically it. This is basically Newton's law right there, and it's grade 11. It's grade 11 DBE 2018 question paper. It was nice. It was nice. It was nice. It was nice. So let me set up my marker right there, and then we dive into action. Oh yeah. Then we dive into action. Good. So this is question number 3. Question number 3. And then worry. A box with mass of 45 kg is pulled with a force of 90 Newton at an angle of 50 degrees to the horizontal. And then the box moves at a constant speed. I want you to highlight this part first. Constant speed. The word constant speed, I've explained this a lot of times to those who attend my lessons. Constant speed. The moment you hear constant speed, just know about Newton's first law. This probably means one's law. It is the one that talk about constant speed right there. Why? Because on Newton's first law, a body will remain in a state of rest or moving at a uniform velocity. Uniform velocity unless acted by an unbalanced force. So the word uniform velocity refers to constant velocity. This is an unchanging velocity. So the conclusion that you have to draw over this box is that F net equals to 0. I've illustrated this many times and many times and many times. So for today, I'll just let it slide, right? And then what I want to do is that I want you guys to look at 3.1. Normally, they have to ask for the law, definitions, and etc. So for this one, they ask for definition of kinetic frictional force. And then kinetic frictional force, this basically the force that opposes the motion of a moving object. Actually, they told us already it was being pulled. So there is kinetic frictional force which relate to the speed and opposing the motion. And then we 3.2 says state Newton first law of motion in words. I've explained the law. I'll pass. I want to dive into the calculation first. And then the first question says, calculate the magnitude of horizontal component of the applied force. You know. Let me draw the freeboard diagram here of this thing. We have weight, ne? And then here we have normal force, and then you also have the applied force at an angle, and then you have kinetic friction right there. I'll write Fk, and then I'll write normal force, and then I'll write weight, and then this force applied. Oh, and then the force applied, because it is an angle, we'll break it into components. We have the vertical component, and then we have the horizontal component right there, which is Fx, and then they want Fx. Remember guys, force applied can make a vector diagram. Force applied can make a vector diagram. How? Let's take for example, I have the force applied or the vertical component of force applied, which is going upwards, but in this case I can just say downward, doesn't really matter. And then I also have the other component, which is the horizontal component, which is going to that side right there, but in this regard I just draw it the other way around. And then I have my hypotenuse, which is the applied force itself right there. Remember, my angle here, you can see this is my angle right there. So here my angle will be 50-degree right there, and then this is Fy, and then this is Fx, and then this is Fe, the real force applied. And then they want this one, Fx. So this is actually going to be Fx is equal to, and it is the adjacent. This adjacent, remember we have adjacent, we have O adjacent over O hypotenuse equals to O cos theta. We have cos theta. Okay, let me write it like this, cos theta. And then that means, sorry, over here we are going to have F cos 50-degree right there. And then from there, what is my force applied? It is 90. It is 90 cos of 50 degrees right there. Cos of 50 degree right there. What is my answer? What is my calculator? Let me calculate for you. I think you are sleeping, and then sure. And then this is equal to 057,85 newtons. They only asked for the magnitude. You don't write a direction. They want the size only. So that's all you do right there. Mara, let's proceed. Let's proceed. Let's proceed. Then the second question says 3.4. Calculate the magnitude of the normal force. Magnitude of the normal force. Guys, please bear with me as I try to illustrate this. Back to my free body diagram. I need the one the normal force. The one O normal force. Look at this. O normal force is part of the vertical motion. It's part of the vertical motion. And my vertical motion is composed of Fy and normal force and then O weight. That means I'm going to say F net. I've already illustrated this when I was drawing introduction to Newton's law, and then this equal to ma. Right. And then guys, what are my forces? My forces are Fa, this is the normal force, plus Fy minus W equals to 0. That's where we start. Relax. Do not confuse these two things I'm about to explain right now. My question said the box is moving at a constant velocity. Where is it moving? On the horizontal level, right there. It is going that side at a constant speed, not going upwards or something. Yeah, one of the boxes sliding on the ground. That means it has stayed on the ground, meaning all upward motion and downward motion have remained constant, meaning the box isn't jumping or bumping or anything of that regard. That means its motion is constant. Simple as that. Simple as that. And you know, acceleration. I've explained this a lot of times, man. Acceleration, this rate of change of velocity. There's something wrong with my marker, but fine. Rate of change of velocity. This actually means the way in which velocity is changing. Damn, not that one, not that one, not that one. Let me erase, okay. It basically means, Ori, what is happening right there? Probably I mistyped it. Let's bear with me. Okay, I've probably mistyped it, but that is fine. That is fine. And then that is fine. I'll go back to the top. Just bear with me for a moment, please. And then I will go back to the equation. And then we cook. I need to are cooking this one. We're cooking. Okay. There's literally something wrong over. I think it's over here. Damn it. Okay. Let me exit, and boom. And then I'll just go back to the equation. Then everything is fine. Okay. Let's go back to the equation and finish up. Yes, thank you, laptop. Okay, so let's back to our work. I was still explaining, Ori. Oh yeah, the rate of change of velocity, which is the acceleration. This is basically what you have to know. That it means, Ori, it is the way that the velocity is changing per unit time. Per unit time. And then because I told you the upward and downward motion is remained constant, it means, sorry, its acceleration is equal to 0. That is it right there. That is where my 0 comes from. That is where my 0 comes from in that particular regard. That is it. That is it right there. And then they're asking for the normal force, but do I actually have everything that I need? I have OFY, I can find it, and then W, I can also find it. That means I will say Fn, I'm doing it, the subject of the formula right there. Okay. Um, hey guys, okay. And then here I have Fn equal to mg, I changed weight, and then minus f sine theta right there. And then this equal to 0.45 into 9.8, then minus 0.90 sine of 50 degrees right there. Then I can just do this on a calculator and find my normal force right there. It's very simple, straightforward. This Newton first law equation, simple and straightforward. This 45 into 9.8 minus 90 sine 50 degrees, and then this equal to 372,06 newtons. Yeah, that is it. We are fine. I hope we are fine. I hope we are basically fine. We have the normal force. We have the normal force right there. This is my normal force. The only one, the magnitude. And then we recalculate the coefficient of kinetic friction. The coefficient of kinetic friction. I don't know. I will erase this one, but I also hope when I erase, I will not have a problem. I just hope so. Damn. Okay. I will erase this. Gone, and gone, going. This reminds me of Mr. X, my former teacher. Okay. And then right there, Wambile. Okay, and then here we're going to the 3.5 question. Is 3.5, calculate the coefficient of kinetic friction. To have the coefficient of kinetic friction, mu k, we know about the formula which says Fk equals to mu k times normal force, right? But do we have the frictional force? No. Do we have normal force? Yes. We want what? U mu k. That means we have to first find U f k. Then fine. If I check on my motion, my vertical motion, on my free body diagram, I only have fx, this one, and ufk, this one, right? And then that means only my f net will compose of only two forces, right? Which are namely fx and the opposing force, which is fk, equals 0. Why? Because on my equation they told me it is moving at a constant velocity. See, one now is different. It's different because for the first motion I told you guys it is about the upward and downward motion that was currently taking place. Ne? So in this case it is different. And then what is my fx? My fx is 90 cos of 50. Cos 50. There's something wrong with my pen, but fine, as long as you see equals to 0. And then this 5, and then 90 cos 50 is equal to fk equals to, I transpose this to the other side and it becomes negative, and then I divide both sides by negative, it becomes 57,85 newtons right there. And then I want O coefficient of kinetic friction. I'm going to see what was my normal force again. What is my normal force? My normal force was 372,06, and then I'm going to say Ori 57,85 is equal to mu k, which is coefficient of kinetic friction, multiplied by 372,06 right there. And then O mu k equals to, let's divide 372,06 right there, and this equal to 0.16, and that is it. There's no unit, guys, no unit. And I have explained to you already why the coefficient of kinetic friction doesn't have a unit, because it is a ratio. And this is a force and this is also a force. So a force divided by force, and if force is calculated in newtons, they are going to cancel and we'll be only left with the number right there. I hope we are fine. I hope we are fine. And then we're moving. This is an explanation based question. Will the coefficient of kinetic friction change if the angle applied of the applied force decrease? Write yes or no and give a reason. Oh, there's someone will be saying decrease, increased, whatsoever. And no, guys, the answer is basically no. It's no. No, before I say anything, just tell them no. Just tell them no. Why? The coefficient of kinetic friction depends on the type of surface. They didn't change the surface, they changed the angle. So, coefficient of kinetic friction is a constant value that depends on the type of surface. As long as it is still moving on the same surface, the coefficient of kinetic friction will remain the same. The only place that it will change, let's assume then there was an incline, it was going up an incline. The coefficient of kinetic friction in this case of incline will be different to this one on the horizontal. So you tell them or no, coefficient of kinetic friction depends on the type of surface. Now, I think we have came to the end of the section. So that is 16 marks right there. We got marks. You have already passed the exam. I have saved you. Yeah. This is basically the end of the section. Done. Stop recording.